Good morning, folks. No, definitely don't worry about a thing. Everything's going to be okay. So how are we doing? Hopefully we're all doing all right. And we're now into our fourth lesson on differentiation, which is going to be differentiating quadratics. And hopefully what you're going to find is the further we get into this, almost the easier it gets. As long as you keep doing the practice, this gets easier and makes more sense and is therefore more enjoyable. Right, here's our first couple of examples. Differentiating quadratics. Find dy dx given that y equals x squared plus 3x. We'll worry about this other one in a moment. So write that one down and pause it, and then we'll carry on. So I'm asked to do this, so the first thing I do is I write down dy over dx, and then using the rules we talked about yesterday, the power is 2, so we drop the power by 1 and we multiply by that power. So we multiply by the 2, so that gives us 2x. The power drops by 1 from 2 to 1, which we just leave as nothing. Then we come on to the second term, and we'll do the same idea here, but think about what happens. If you take 1 off the power, you're left with to the power 0. So you would be multiplying by 1. 3 times 1 is 3 times x to the power 0. Now 3x to the power, anything times x to the power 0 is 1. So for that reason, whenever you've got single x's, you always just have this number, because 1 times that number will keep it the same. So that gives us dy over dx equals 2x plus 3. If you didn't get that, rewind it and watch it again. Now we're coming on to the other situation that we might get here. So we've got dy over dx is going to equal times the coefficient by the power. 8 times 2 is 16. Drop the power by 1 to x. And now what happens here? Well, if you think about what we're talking about, x to the power of 0, if you took 1 off that, you'd have x to the power minus 1. But remember, the first thing we do is we times by the power, don't we? So we would be timesing by 0. Times something by 0, you get 0. So the minus 7 just disappears. Numbers on their own disappear. Okay, so then the third one we're going to have is more of your standard quadratic, where you've got squareds, x's and normal numbers. So we've got 4x squared, take 3x plus 5. Start off by writing dy over dx. And that's going to give us 2 times 4 is 8x. I just lose the x here to minus 3, and I lose the plus 5 altogether, and 8x minus 3 is my answer. Okay. Now in this question, let fx equal 4x squared minus 8x plus 3, where we're asked to find the gradient of y equals the function of x at the point 1/2 0. So this isn't actually telling us to differentiate, but that's what we're going to need to do, because that will give us the key to the gradient. Remember, that's why we were doing all of this. So the first thing to do is differentiate. So I can do that using f dash x or using dy over dx. Remember, try to alternate between them if you've got a choice in the question between the two, because it just helps you get used to it. So first of all, 2 times 4 is 8. Drop the power to 1. X's, we just keep the coefficient, and the plus 3 disappears. So this is our function that tells us the gradient. And what we need to do now is say, right, when x is 1/2, what will that gradient be? So when x equals 1/2, the gradient is going to be, and we're just going to pop a half, substitute a half into there, and that'll get it to us. So 8 times a half is 4, 4 take 8 is negative 4. So that is the answer to the first one. Right, now let's have a look at the second part of this question. Find the coordinates of the point on the graph of y equals a function of x, where the gradient is 8. So we're going to be using the same one that we were looking at already. So we know that the function of x, so that is our gradient, is given by 8x minus 8. Well, if they're saying the gradient is 8, we can just make that into an equation there. 8x minus 8 equals 8. So I just add 8 to both sides to give me 8x equals 16, and divide by 2, divide by 2, divide by 8, because we've got 8x, haven't we? And x is equal to 2. And what do we need to know? We need the coordinates of the point. So we're looking at the point 2 and something. So to find what y was, we go back to the original point we had, which would have to be y equals 4x squared minus 8x plus 3, because that's what they said the function of x was. So in that instant, we substitute 2 in, and y is going to be 4 times 2 squared, take 8 times 2 plus 3, which is 2 squared is 4, 4 fours are 16, 8 times 2 is 16, so that's take 16 to get us to 0, and then plus 3, which all gives us 3, and therefore our y coordinate is 3. The final part to this question, and our final example for today, is to find the gradient of y equals fx, so that's our initial function, at the points where the curve meets the line y equals 4x minus 5. So thinking about that, what was our original equation? It was y equals 4x squared minus 8x plus 3. So we want to know where these two lines cross. Now you could do that by chucking it into your calculator, which is absolutely fine in a question like this because it hasn't told you not to. Or you could just say that's going to give us a little simultaneous equation, easy one to set up, where we say that is equal to that. So we've got 4x squared take 8x plus 3 is going to be equal to 4x minus 5. When we've solved this, we'll have a couple of values of x, the two places where the straight line crosses the curve, and we can find out what the gradient was by putting that into 8x minus 8, because that's our gradient function. So let's solve this. If I take 4x and I add 5 to both sides, we'll have it equaling 0 on this side, so it's still got 4x squared. We've got minus 12x, and if we add 5 to 3, we've got 8. Now they all look like 4 goes into them, so if we divide everything by 4, we get x squared minus 3x plus 2 equals to 0. Does that factorize nicely? 2 times 1, yeah, it does, and both negatives, so minus 2 minus 1 equals 0. So from that we know that the brackets must equal 0, so x equals 1 or 2. When x equals 1, the gradient is going to equal 8 times 1, because that was, remember, we had dy over dx is 8x minus 8. 8 times 1 take 8, which is 0. And when x equals 2, the gradient is going to equal 8 times 2 is 16, take 8, which is 8. And that is that for today. Just before we do, I'll just remind you what that looks like on the calculator. So popping it into your graph function, you put those two in like that. Remember, you hit draw, and then to get your solutions you'd have gsolve, and you'd have your intersections, which gives you x is 1, y is -1. So there's your x is 1, and if I press E across there, it takes us to 2, 3, and that's that bit done. Right, so for today's work, if you're looking at page 265, exercise 12D, and question 1, you just need to do A and E. As long as you can do those, then that's fine. If you make a mistake, then do all of question 1. Question 2, again, if you could do A and E, fine, then that's great. If you make a mistake, then go back and do the rest of those questions, and then all the other questions. So that's 3, 4, 5, 6, and 7. And let me know if you have any issues with that. Okay, enjoy. Goodbye, folks.